All right, how's it going, guys? Today we're going to be going over the difference of squares and perfect square trinomials. So, the difference of squares is going to be an expression in the form a squared minus b squared. And that's called the difference of two squares. And pay attention that it is a squared minus b squared. If it's a squared plus b squared, it's not going to work. That's why we have the name difference of two squares. It has to be the difference, or you'd have to be subtracting two different squares. So, before we actually give you what a squared minus b squared will equal when you factor it, let's go ahead and actually FOIL out these two problems down here. So if we FOIL them out, we'll get x squared, x squared minus 5x plus 5x minus 25. Okay, and remember, FOIL stands for first, outer, inner, last. So if we FOIL out x plus 5 times x minus 5, we get x squared minus 5x plus 5x minus 25. And if we add like terms, we get x squared minus 25. We can see right here that negative 5x and positive 5x, when you add them up, they cancel each other out. So we're just left with x squared minus 25. For the second thing we need to FOIL, the second expression we're going to FOIL, we have 4x plus 3 multiplied with 4x minus 3. And if we FOIL it out, we get 16x squared. Sorry, it's supposed to be minus 12x plus 12x, then minus 9. And same thing as before, we can see the middle two terms end up canceling each other out, and we're left with 16x squared minus 9. So what do we actually notice about these answers? The first thing you can see is that the first term and the last term are always squared. So if we look into things that we were FOILing, we have x squared and we have minus 25. Those are both squares of whole numbers, right? X squared is, sorry, if you square x, you get x squared. You square 5, you get 25. Same thing here, 16x squared. If you square 4x, you get 4x squared. And if you square 3, you get 9. So the first and the last terms are always going to be squared. Are always going to be squared. The middle two terms of the answers are all, they always cancel, right? We have negative 12x plus 12x. These two right here ended up canceling each other out. Negative 12x plus 12x gives you 0x, or it just goes away. Same thing with the first one, negative 5x plus 5x. If you add them up, it gives you 0x. They cancel each other out. So the difference of two squares, what the factored form of a squared minus b squared will be a plus b multiplied with a minus b. Like we saw in these two expressions that we FOILed out, we have x plus 5 multiplied with x minus 5, or a plus b multiplied with a minus b. Same thing with the second one. It'll be a squared minus b squared. The factored form of that will be a plus b multiplied with a minus b. So let's go ahead and actually factor out a trinomial when b equals 0. For this example here, we have x squared minus 16. We're not actually going to find the factors of AC and do it that way. We're going to go straight into factoring this with our difference of squares formula. So we have x squared minus 16. What I like to do is I like to rewrite this into two squares. So I'll rewrite x squared minus 16 into x squared minus 4 squared. And now this is very similar to what we saw in the last slide of a squared minus b squared, right? And if we compare the two, we can actually set our a to be equal to x and our b to be equal to 4. And once we do that, we need to just remember what we said our factored form of a squared minus b squared would be, and that was a minus b multiplied with a plus b. So we have our a, which is x. So x minus our b, which is 4, multiplied with x plus 4. And that's the factored form of x squared minus 16. Okay? So let's keep going. Do the same things with number 1, 2, and 3. We have x squared minus 64. What I'm going to do is I'm going to break this down to get it into a form very similar to a squared minus b squared. So x squared minus 8 squared. 8 squared is the same thing as 64, so I can do that. And if I do it like this, I can see my a term would be x, and my b term would be 8. Right, because it's in the form a squared minus b squared, so that makes a my x and my b my 8. All I need to do now is put this into the factored form we just learned of a minus b multiplied with a plus b. So x minus 8 multiplied with x plus 8. Remember, it's a minus b multiplied with a plus b. That's where I'm getting it from. For number 2, I'm going to do the same thing. I like to break it down so I can see exactly what my a and my b would be. So I have 4x squared minus 1. 4x squared will be the same thing as 2x all squared minus 1 squared. 1 squared is still 1, so we can do that. And I can see that my a will be 2x and my b will be 1. So if I put this into my factored form, I'll have 2x minus 1 multiplied with 2x plus 1. Remember, it's a minus b multiplied with a plus b. It doesn't really matter which order you put it in. You can put a plus b multiplied by a minus b. It doesn't really matter. All right. And now for number 3, we're going to do the same thing. I like to break it down, so that's what we're going to do. 36y squared, that's the same thing as 6y all squared. And we're going to minus that with 49z squared is the same thing as 7z all squared. So 6y squared minus 7z all squared. From here, I can see that my a is going to be 6y. It's the first term b squared, and my b will be the second term b squared, so 7z. So I want this in the form a minus b multiplied with a plus b. So when I do that, I get 6y minus 7z multiplied with 6y plus 7z. And that'll be the factored form of number 3. Okay, so number 4 and number 5, we have combinations and mixed practice. And remember, whenever we're trying to actually factor something out or simplify something, the very first thing you always want to look for is look for a GCF. You always want to do that first. If you simplify from the beginning, factoring and doing everything else afterwards will be much, much easier. So for number 4, the first thing we're going to do is look for a GCF. And we see we have a GCF of 3. So I can factor out a 3. And when I do, I'm left with 4x squared minus 25. And once I factored out that 3, I can see that I actually have a difference of squares inside of the parentheses. So like we did before, I'm going to take the 3 to the side. I'm going to kind of ignore it for now while I factor out what's happening inside the parentheses. So 4x squared is very similar, or actually it's the exact same thing as 2x squared, and minus 25, we just put minus 5 squared. It's the same thing. And now it's more in the form of a squared minus b squared. So I can see that inside the parentheses, my a equals 2x and my b equals 5. So now I'm going to change out a factor what's happening inside the parentheses with the rules we just learned. It's going to be a minus b multiplied with a plus b. So 2x minus 5 multiplied with 2x plus 5. It doesn't really matter which way you order this stuff up, since they're all being multiplied together. You can put it in any way that you want. So our factored form for number 4 will be 3 multiplied with 2x minus 5 multiplied with 2x plus 5. All right, and for number 5, what we're going to do here is we're going to change this into a difference of squares. So x to the 4th is the same thing as x squared all squared. And 81 is the same thing as 9 squared. So we're going to do a difference of squares here, since we do have a difference of squares. We have a squared minus b squared. So what we can do or sorry, what we can say is a will be x squared, b will be 9. So now we're going to factor this out, and when we do, remember it's a minus b multiplied with a plus b, so x squared minus 9 multiplied with x squared plus 9. But we're not fully done here, because we see when we factored out number 5, x squared minus 9 is actually a difference of squares as well. So we need to keep factoring down from here. X squared plus 9 is a difference of squares of x squared minus 3 squared. X squared plus 9, we cannot factor that out. It doesn't go towards a difference of squares, since it's a positive, an addition in between the two squares, and we need a subtraction. So x squared plus 9, we cannot break down anymore. X squared plus 9 is prime, so we leave it alone. But with x squared minus 9 or x squared minus 3 squared, we can break that down. Our a here will be x, our b will be 3. So we can put it as x minus 3 multiplied with x plus 3 multiplied with what we didn't break down with the x squared plus 9. So the x squared minus 3 squared gave us those two parentheses, and the x squared plus 9 gave us that last one. So this will be our factored form for number 5. Okay, so let's keep going. Now we're going to talk about perfect square trinomials. A perfect square trinomial is the product you obtain when you square a binomial. So we're going to FOIL these binomials below in order to discover a pattern that makes it easy to factor. So we have x plus 2 all squared. If we FOIL that out, we get x squared plus 2x plus 2x plus 4, or we get x squared plus 4x plus 4. For 3x minus 5 squared, if we FOIL this out, we'll get 9x squared minus 15x minus 15x plus 25. Or if we add like terms, 9x squared minus 30x plus 25. So if we if we FOIL out both these binomials, this is what we get. So what do we notice about these? The first term and the last term of the trinomial are always squared. We're squaring some type of number. So we see here the x squared, if you take x and you square it, you get x squared. With 4, if you take 2 and you square 2, you get 4. With 9x squared, if you take 3x and you square the 3x, you get 9x squared. And same thing with 25. If you have a 5 and you square the 5, you get 25. So the first and the last term of the trinomials are always squared numbers. The middle term of the trinomial will be twice the product of the terms of the binomial. Or in other words, let's say with number 2, the 3x minus 5 squared, what we can do for to figure out the middle term, we'll multiply the 3x and the negative 5. That gives us negative 15, and we just need to double it, and that gives us our middle term of negative 30x. Well, it should be negative 15x there, sorry about that. So the middle term of the trinomial is always twice the product of the terms of the binomial, or you multiply the two terms in a binomial, you multiply them together, then you double it. That will give you your middle term of your trinomial. And so perfect square trinomial with a positive middle term gives us a plus b squared. That's the first thing we FOILed. We started with x plus 2 squared, and we ended up with a perfect square trinomial of x squared plus 4x plus 4. For a perfect square trinomial with a negative, we'll get a minus b all squared. That's the second one. We have 3x minus 5 all squared, and that gave us a perfect square trinomial of 9x squared minus 30x plus 25. So let's go ahead and look at some examples. So for number 1, we have 25x squared plus 90x plus 81. So we're going to factor this out. But before we actually factor this out, we're not always going to tell you when a trinomial is perfect or not. We're not always going to tell you. You won't always know. So what we need to do first is we need to check if it is a perfect square trinomial or not. If you remember from the previous slide, what we said in the bottom here was that the first term and the last term of the trinomial have to be squares of another number. And the middle term has to be twice the product of the terms of the binomial. So first thing we're going to do is check the first and the last terms of the trinomial and see if it's a square of another number. 25x squared is the same thing as 5x all squared, and 81 is the same thing as 9 squared. Now the next thing we need to do, and we need to make sure of, is that the middle term of 90x is going to give us 2ab, a positive 2ab, right? That's what the equation in the previous slide gave us. It has to be a squared plus 2ab plus b squared. So if we add 2 times our a of 5x plus our b of 9, this right here should equal our 90x that they gave us. And if it does, that means we have a perfect square trinomial, and we can factor out with the rules we just learned. So let's figure out what 2 times 5x times 9 actually is. We'll bring down that 5x squared. 2 times 5x is 10x, and 10x times 9 is 90x. And 9 squared, we're just going to bring it down. And we see that this 90x is what we started with, and that's how we know that it's a perfect square trinomial. If we got anything other than 90x in this case, it would not have been a perfect square trinomial, and you'd have to factor some other way. All right, but from here, we do know it's a perfect square trinomial, so we can go ahead and use the rules that we learned. And in this case, it'll be a plus b all squared. And that's because our middle term right here is positive. That means our factor also has to be positive. So our a is 5x, and our b is 9. So 5x plus 9 all squared. And that is our factor form for number 1. For number 2, we're going to do the same thing. First thing we're going to do is make sure that it is a perfect square trinomial. So 9x squared has to be the square of some number. And we can see that 3x squared equals 9x squared. So that's good to go. 49 is the same thing. It's the same thing as 7 squared. 7 squared is 49. So that's a square of another number. That's good. So now all we need to do is to make sure the middle equals negative 2ab. You need to make sure it equals negative 42x. So we have minus 2 times our a, which is 3x, and times our b, which is 7. This needs to equal negative 42x. So let's go ahead and solve it out. We have 3x squared, and we have negative 2 times 3x, which is negative 6x. Negative 6x times 7 is negative 42. So we have negative 42x plus 7 squared. And we see this negative 42x equals what we started with. So we know that this is a perfect square trinomial. And since it is a perfect square trinomial, we can go ahead and just factor how we always do. Or sorry, not how we always do, the factor with the rules we just learned. So in this case, it's going to be a, which is 3x, minus b, which is 7, all squared. And it's going to be minus 7 since our middle term is a negative. If our middle term is a negative, the sign of the factor has to match that. So it'll be a negative inside the factor. So we get 3x minus 7 squared. All right, and for number 3, we're going to do the same thing we always do. Double check that it is a perfect square trinomial. 64x squared becomes 8x all squared. 1 is the same thing as 1 squared. And now we need to make sure that negative 16x equals negative 2ab. So minus 2 times our a, which is 8x, and our b, which is 1. And we can see that negative 2 times 8x times 1 is negative 16. And that's what we wanted. So we know this is a perfect square trinomial. And since it's a perfect square trinomial, what we can do is use our rules, which will be a minus b all squared. Our a is 8x. Our b is 1, so minus 1 all squared. And we use a negative 1 instead of a positive 1 because our middle term is negative. If our middle term is negative, that means our sign in the factor has to match that. So it has to be 8x minus 1. All right, we have number 4, number 5. Let's go ahead and work one of them out. So, like I said before, whenever we're trying to factor something out, the very first thing we always need to do is check if we have a GCF. Since if we have a GCF, we can factor it out, and it'll make factoring it much, much easier. So the first thing we're going to do is look for a GCF. For number 4, we have 12x cubed minus 36x squared plus 27x. So I see we have a GCF of 3x. I'm going to factor that out. And when I do, I'm left with 4x squared minus 12x plus 9. So I see I have a 4x squared in the beginning and a 9 at the end. Those are both squares of another number. So that kind of makes me a little suspicious that this might actually be a perfect square trinomial. So we're going to double check that and see if it is, and then we'll factor. This 3x, we're going to leave it alone for a bit. So we have actually just change that into 2x all squared. So then, since 2x will be our a, we have 2x all squared. We have 9, which will give us 3 squared. And now we need to make sure that minus 2ab equals negative 12x. So minus 2 times our a, which is 2x, times our b, which is 3. This has to equal negative 12x for this to be a perfect square trinomial. So we're going to bring down the 3x. It doesn't really matter for right now. We'll leave the 2x squared. And we see negative 2 times 2x is negative 4x. Negative 4x times 3 is negative 12x. And that's exactly what we wanted. This negative 12x equals this negative 12x. So it is a perfect square trinomial. So we know it's a perfect square trinomial. So now we can just use our perfect square trinomial rules. It'll be a minus b all squared. So 2x minus 3 all squared. And we use a minus 3 instead of a positive 3 since our middle term is negative. And the sign of the middle term has to equal the sign of the factor. So our factored form for number 4 is 3x times 2x minus 3 all squared. All right, and for number 5, I'll leave that for you guys to do on your own. We're going to post the completed key online on Canvas so you can double check your work through that. And that's it, guys. Hopefully this helped.